Okay, so this is the first video in a series of videos which are designed to help people get up and running with Provus. And seeing as it's the first video, I'm going to be starting right at the beginning here. When you're first given Provus, it'll be in some kind of compressed file, and you're going to want to drag that somewhere in your system, and you're going to want to right-click and extract it. So you'll end up with a folder that looks something like this. And you're going to want to find the Provus executable here and double-click that to launch Provus. Once you do launch Provus, you might want to pin it, right-click and pin it to your taskbar or something just to make life a bit easier. Also, on your first launch, you might be greeted with a prompt to enter your license ID and activation code, which should have been supplied to you. So you'll notice once Provus launches, there's two windows. So we have the console on the left and the viewport on the right. And we want to load our first Provus project. So what we're going to do is we're going to go to the console window and we're going to go to this file drop-down menu and we're going to click load project file. And you also should have been provided with a project which consists of synthetic data. So you want to go to wherever you've saved that and you're going to want to select this .prj file and click open. And so Provus will load all the contents of that project, which you can see both in the viewport and now has populated our world tree in the console. And so for this video, I'm just going to go through an overview of the functionality that's included in Provus. And to do that, I'm just going to go through all of these tabs in the Provus console and basically explain how to use them and what they do. So for the first tab, we're here in the world tree, and you can see this is essentially a list of all the entities that have been brought in with your Provus project. And everything that gets brought into Provus is assigned an object type. So our data profiles, in this case, we're looking at borehole data, and they are assigned the data profile object type. Note that the naming scheme here is the whole number followed by max or null, and in this case, the max or null refers to the transmitter loop. There's two transmitter loops, one which was designed to be maximally coupled to some structure in the subsurface, and the other which was designed to be null coupled to that same surface. So that's why there's a max and a null version of these holes. So those are data profiles in this case. So if we keep going down our list, we run into something called test ribbon, which if we look at our viewport here, is this lilac ribbon conductor, which has been created. And this has the object type of a ribbon, right? So there's two types of conductors in Provus, ribbons, and then our second one, which is called test plate, directly under our test ribbon, is the other type, which is a ribbon plate conductor. So this one is more analogous to Maxwell plates, which you're familiar with. So those are the two types of conductors that we'll be working with in Provus. Under that is something called the global rotation point, and that's this little dot up here. And essentially, it's the point in which your ribbons will be rotated around in the viewport. So that will become important later. And then finally, under that, we have our transmitters, which have their own unique object type called transmitter. And you can see they're rendered in our viewport here in red. And there is arrows which indicate the direction of current flow. So in terms of functionality in the viewport, or in the world tree, sorry, if we click on a given entity here and we right click, we'll have some options available to us. So a fairly important one would be the ability to center viewport. So as your project grows, you might find yourself getting a little confused or your vision obscured, and you at some points you will want to recenter your vision in the viewport. And so one way to do that is to go over and find the conductor or the profile which you need to be looking at, and you can right click and click center viewports, and it will bring you in line with whatever you're trying to look at in the viewport. So it can be helpful basically just for orienting yourself, because it can get a little confusing at times. Next, if you right click, there'll be an option called open dialog. And so if you do that, it'll generate a new window, and this is what's called an object dialog. In this case, it's a ribbon dialog because I right clicked on our test ribbon. But essentially, I'll be going into these more in depth later, but it is essentially where you go to change all the parameters of whatever objects you're interacting with. So that will become very important, and you can access it from the world tree. Additionally, some objects like the data profile, if I open the object dialog, there'll be a box here called object type dialog. So for the data profile object dialog, we can change the color, the thickness of the boreholes as they're rendered in the viewport. But if I click this object type dialog, these changes will now be applied to all data profiles in the project instead of just doing one at a time. So that can also be very useful. So you'll see if I wanted to change all the colors or the thicknesses of all the holes in a project, this is where you want to go to do that. So moving on, or actually there's another very important thing about the viewport or about the world tree is the ability to toggle to hide things in the viewport. So as I mentioned, like as your project gets bigger, there'll be things that you just don't need to be seeing in the viewport that is just cluttering stuff. So you can go over to your world tree and you click this checkbox. If I am done with this plate and then I don't need to see it anymore, I can just hit this checkbox here and that will remove it from the viewport. So that's another very, very important feature of the world tree. And so now we're going to move on to the plotting widget. So you can see here we have a list of all of our data profiles, and in Provus a data profile is comprised of one component. So you can see as we go across here in the columns, we have our profile name, the component, the associated transmitter loop, and then we have waveform, channel sampling, and base frequency. So these are essentially read in from a subdirectory in your project directory called channel options, and they're basically text files that delineate the transmitter pulse, the channel sampling, and the base frequency. So in this case, these have all been populated in your synthetic project, but if you were to be creating your own project, bringing in your own data, you might have to generate these files so that Provus can read in your data properly, and there'll be information on the expected formatting of these in another video. And then finally at the end we have it's a unique identifier string here for each of these data profiles. So what do I want to do if I actually want to plot up my data and see? So we go down here and we have two options. We can either create a plotting group. So to do that you would put some name like plotting, like plot group 1 or something. And then you would be able to go through and manually check whatever data profiles you're interested in viewing. However, the easier way generally is to click this common line button. And so that you'll note if I click this drop down menu now, it has automatically grouped all the components for each hole into their own plotting groups. So I can then just pick whichever hole I am interested in looking at and click plot, and it will generate this window here. And so this is how you'll be viewing your data in this window here. So I'll go over these plotting windows. So the first thing is the ability to select what channels you're viewing. So obviously you might not want to be viewing all time channels. So you can go ahead and click none and that will clear it. And then you can go through and select whichever channels you're interested in viewing. And also of note here at the bottom, we have the calculated primary field in red. So I haven't run a simulation yet. That's why it's sort of flatlined there. And then we have the total field, the observed total field in black here. And so the idea being this can be kind of a useful QA/QC tool. So once you run your model, this red line should more or less be following your observed total field unless there is a really strong conductor, or if it isn't and there is no strong conductor, then it's likely that you have some kind of geometry error either in your hole or your transmitter loop. So it's a good sort of tool to check that. Another thing about these plotting windows, so you're able to zoom with your scroll wheel and hold left click to drag to reposition the profile. There's a button down here to max your vertical scale, so you can kind of reset your y-axis there to make sure you're getting an accurate view of your profile. And you can also double click on a given profile and that will bring it to the forefront, so if you're only looking at one component, and you can double click again to reset it. So that's our plotting windows. That's how we view our data. And now I'm going to go over to the simulation tab. So the simulation tab, we can see similar to the plotting widget. We have a big container here containing all of our data profiles. And on the left here, we have this project conductors container, which will contain a list of all of the conductors in your project. So in this case, we only have these two conductors, this plate and this ribbon. So that's what's populated here in this container. So let's say I was interested in running a simulation with both of these conductors for a given hole. Let's just say this hole here, which is 231213 in between these conductors. So to do this, we need to create a simulation request. And the way you do this is can be a bit unintuitive. So you could click this common line button, but then that will create a simulation request for every hole in the project, which can be a bit overkill sometimes. So what you want to do is you want to go to this name column and you want to double click so that your cursor is flashing at you there. And then you can input whatever you want to call the simulation. So I'll call it just the whole name here. And then you want to go through and you want to find your hole that corresponds to whatever hole you're trying to model. So I wanted 231213 max. So I'm going to select the X, Y, and Z component here. And then I'm going to go over to the project conductors, and I am including both of them in our simulation. So I'm going to check both of them. And then finally, I'll come down here and make sure I activate the simulation by clicking the checkbox. And so another thing you can do is if you double click your simulation, it'll bring up this window, which basically just tells you what is involved in the simulation. So what conductors, what profiles, etc. And finally, you want to click compute. And so it'll go red here to let you know that Provus is working, and then green when it's finished. And okay, great. So our simulation has just been run. So we want to go back to our plotting widget and bring up the hole that we just ran the simulation for, which is this hole right here. And so you can see these holes have not obviously been fit in any serious way, so the data does not fit, but you can see our predicted data is plotted in green here against our observed data in orange. And so that's sort of how you're going to be interacting with your models versus your observed responses. So another thing to mention, if you select a conductor in this project conductors container, you'll notice that these options under here become available. And so the first three here, points per mode, number of sign modes, and number of radial modes. These parameters basically affect essentially the more modes, the more computationally intensive it becomes, but potentially the more accurate your response is. So you might not find yourself changing these that often. But so for instance, one example would be if you had a conductor that you knew was responsible for most of the or that was contributing to the response downhole a lot, and then one conductor that was, let's say, maybe far away that wasn't contributing as much, you could maybe increase the modes for the one that was contributing a lot and decrease it for the further away one because it's less important, and that might be beneficial to you. But importantly, below these is the ability to save, delete, and save all conductors in the project. So this is really important. Generally, when I'm using Provus, if I come to a point where I'm fairly satisfied with a conductor, but I want to keep tweaking it a little bit, what I'll do is I'll go to the simulation tab, I'll select it, and I'll click Save Conductor, and I'll just save it under a slightly different name. So if this is called Test Ribbon 1, I would click Save Conductor, and I would save it as Test Ribbon _ V1. And then I just know that I've preserved the state of that conductor, that I can go back to it any time, and I can keep changing up the shape of my conductor without worrying that I'm going to lose all my progress. So that's a really, really important feature there. Going to the next tab here, we have the loop library. So I'm just going to maximize this. So the loop library is basically a repository which keeps all of the loops in your project. So you can see here we have the loop that's plotted on some GIS imagery here. And so you'll note that we only have 2 transmitter loops, max and null, but we have 4 entries in this container. And the reason for that is Provus creates a sort of a simplified version of these loops. So for example, if you're using the same loop over multiple surveys, but the GPS points are slightly different and there's a lot of them, Provus will create a simplified version of those loops that also saves a lot on computation. If it's like a really densely populated coordinate or file or GPS coordinates for the loops, it basically creates like a simplified version that's more efficient computationally. So that's what that is. Next, we have induction vectors. So I'm not going to show an example of how they're used in this video, but essentially If you have a really large discontinuity in your data, you can take advantage of that using this induction vector tab here. And basically, you choose the range of stations that the discontinuity is occurring over, and the channels that you're interested in. And what Provus will do is it will create a vector and place it in your viewport, and that vector will be pointing towards the nearest edge of the conductor, and the conductor will be lying in the plane of that vector. So it's a very useful tool when modeling to sort of make sure you're on the right track. Next is the waveform sampling tab. So this is essentially a way to visualize your transmitter pulse and your channel sampling schemes. So it's all plotted up here. And these drop-down menus will have a list of all of the channel samplings and transmitter waveforms that are present in the Provus project directory. So you can kind of come here and make sure that all your time channels look correct and your transmitter looks correct. So it's another sort of QA/QC thing to make sure that everything's going right. Next is the GA link tab. So say for instance, if you were interested in bringing in all of the conductors and holes that you have in your Provus project, and you wanted to bring that into a pre-existing GA project that also has like geology or additional drill hole information, you're able to do that here. So if you either click this hotkey Control-Alt-U, or if you check this tab, it will essentially, Provus will create a GOH5 file containing all of the drill holes and all of the conductors in your project. And so to find that, you want to go to back out to where your Provus folder is, and you want to go to this monitor folder. And so you can see there's two GOH5 files here. And it should be noted that if you check this box and leave it checked, this folder will continuously delete and re-upload the GOH5 files. And it does this intentionally for people with GA Pro licenses, because you can then just set the live monitoring to this folder, and it will then reflect in GA sort of the real-time state of your Provus project. But if you don't have a GA Pro license, you can just, or even if you do, you can just check it and then wait for this folder to be populated and then uncheck it. And what you can do is you can open an instance of GA and just drag the GOH5 files in, one for the drill holes, one for the surface, and then you can see that'll be populated in your GA project, so you can look at it with your geology or any other information that you have in there already. So that is very useful as well. And then finally, these last two tabs are sort of under construction, but the results timeline is essentially once you've run a simulation with a conductor, you can select a conductor and then scrub through the history. So if you've spent a long time trying to model a specific conductor and it's undergone lots of changes, and you want to revert it back to a state where you had a slightly better fit to your data, you could select it and scrub through that timeline and then restore the project to that state. So that's the idea with the results timeline. And then finally, inversion, which is not yet implemented, but coming soon. So just stay tuned, I guess, but essentially it will be really, really advantageous when this is implemented, because as you can imagine, there's so many degrees of freedom and variables in how you create these deformable conductors that some kind of machine assisted fitting would be really beneficial. So that is on its way. And so that's it for this video. And then in the next video, I'll just go over how to actually create these conductors in Provus and how to manipulate both plates and ribbons in Provus, along with a few other things.